Okay, so hello everyone, this is Akshay here, and welcome back to the another great day of our GFG POTD streak and the continuation of our graph playlist. So today's day is, I guess, 313 or 365, and the name of the question is Mother Vertex, right? So before proceeding ahead, if you're on this channel, please like, share, and subscribe so that we can learn, maintain, and grow a streak together. Now let's get started with the question without wasting further time. So we have been given a directed graph. Find a mother vertex. So what is the mother vertex here? Is a mother vertex is a vertex through which we can reach all the other vertices of the graph, right? So for this, in this graph, you can see 0, 1, 2, 3, 4, 5. Let's just go to the dry run now. So it is saying that the 0 is the answer for this particular graph, right? So how you can say that, you can clearly see that 0 is reachable to 2, right? Using this vertex, correct? Similarly, 0 can reach to 1 as well. तो हम यहाँ पे बना लेते हैं यार 1 2 3 4. तो 0 to 2 reachable है, we know that. Now 0 to 1, how we can reach? We can follow this path, correct? So 1 is also reachable. 0 to 3 is reachable, okay? And 0 to 4 is also reachable. You can follow this path, right? So 0 is one of the vertex where we can say that what? It's the mother vertex that we can reach each and every node, right? And also there's given one more condition or a note that if multiple where is there? If there is if there is more than one possible nodes, then return the minimum value, right? So I think 1 is also reachable to each and every node. Can we just check for 1? So for 1 it will be 0, 2, 3 and 4. So 1 is reachable to 0, and now you can follow this path to reach to 2. So 0 is now you can follow this path to 3, and then again this path to reach 4. So okay. So for 1 also you can also reach 0 to 3, 4, but we need to return the minimum one, that is we need to return the minimum in 1 and 0, that is 0, right? I have to not check for 2 3 4, it is reachable to each and every node, but I just check for 0 and 1, and it makes sense, right? So we don't need to maybe do a further dry run for this. So we are now at a good understanding that what are we going to return in this particular question, right? ठीक है, इस क्वेश्चन को कर कैसे सकते हैं यार? So if you have watched my graph playlist, or if you have been along with me in my GFG purity streak, तो BFS और DFS इन ग्राफ ये ऐसा टॉपिक है जो मैंने पता नहीं कितनी बार पढ़ा चुका हूँ, ठीक है? बट फिर भी let's say some of you guys have skipped this video and may not be able to understand till yet. So I have specifically made video for the BFS and DFS in my graph playlist. Before doing this question, please watch this video, and those who have already have a good understanding of BFS and DFS, तो आज का क्वेश्चन तो यार चुटकी बजा के हो जाता, राइट? जरूरत ही नहीं थी कुछ भी करने का, लाइक आप बस देख के कोड कर दोगे, करेक्ट? बट अगेन, so please watch the BFS and DFS video, understand it thoroughly that how it is running, and then come back to this video again, ठीक है? तो मैं एक हल्का सा ओवरव्यू दे दूंगा, मैं सब कुछ ब्रीफ में समझाऊंगा क्योंकि मैंने ऑलरेडी वीडियो बना रखा है. तो कैसे कर सकते हैं BFS, कैसे चलता है यार, और लेवल ऑर्डर ट्रैवर्सल वी कैन से, राइट? तो BFS के लिए हम एक क्यू मेंटेन करते हैं, करेक्ट? जिसमें हम सोर्स नोड, लेट्स से वी आर टॉकिंग अबाउट द सोर्स नोड दैट इज 0, so we push the 0, करेक्ट? फिर हम 0 को पॉप करते हैं, लाइक जो करंट एलिमेंट है उसको बाहर निकालते हैं और इसके नेबर्स को पुश करते हैं. एंड व्हाट आर ऑल द नेबर्स? यू कैन सी 0 इज डायरेक्टली कनेक्टेड टू 2 and 3, so 2 and 3 would be pushed. Now how am I retrieving this neighbors? तो कल का जो POTD streak था यार, there we have done a question of printing the adjacency list, right? And I have this 312, right? And I also इसको सबसे ऊपर मैंने कर दिया, right? तो adjacency list कैसे बनाते हैं आप वो यहाँ से देख लेना, और यहीं पे and that's the same thing is passed here in the parameters. तो GFG अच्छी चीज कर रहे हैं कि they are like giving the question in order, so that's great, ठीक है? तो वापस से ओपन बोर्ड पे चलते हैं अपन पहले, ठीक है? तो 2 and 3 पुश हो गया, देन अगेन द टॉप मोस्ट नोड विल पॉप्ड आउट. तो 2 को अगर रिमूव किया, देन व्हाट आर द करंट नेबर्स, राइट? Immediate neighbors, it is 1, so again 1 will be pushed. Then again we popped out 3. What are the immediate neighbors of 3? It is 4, so 4 will be pushed. Now if we remove 1 again, what are the immediate neighbors? It is 0, but 0 is already part of our queue, right? So that means we need to make one visited array as well, that once we have covered that particular node, we need to mark that as true, right? So that for this one we do not push the same redundant node, right? So I will not push again because it's already marked, it's already covered. So again I will pop out, or I will remove the topmost node of the queue, that is 4. Again 4 has no other neighbors attached to it, and that's it. That you have done a level order traversal for this 0, and what did you get? 0 2 1 0 2 3 1 4, correct? And while you are doing this level order traversal or BFS, you will just maintain a counter. You will do count plus plus whatever the values you are getting pushing inside the queue. And at the end of the BFS traversal, we just check with this condition. If count is equals to v, then what you need to do, you need to return I, right? And what is I? We will have a for loop. So for each vertices, you need to do the level order traversal. मैंने आपको 0 के लिए करके दिखाया, the same you have to do for 1. चलो एक बार और तुरंत से देख लेते हैं 1 के लिए करेंगे तो क्या होगा. So 1, the source node is pushed 1. Now what are the immediate neighbors? Only 0, right? So we remove this and push its neighbors. Then again, what are the immediate neighbors of 0? It is 2 and 3. So I push 2 and 3. Now, what are the immediate neighbors of 2? It is 1. But 1 has already been part of the queue, right? So that will be handled by using this visited array, right? So we will not push anything. Now, again, the 3 will be removed and the neighbors will be pushed. That is 4. 4 has no neighbors. And then you can clearly see that all the nodes were visited in this BFS traversal. And again, while doing the count process, you might have returned to this answer, right? But we need to return the minimum one. तो हम यहाँ पे एक break statement भी use करेंगे, ठीक है? Okay, so that was it for the first approach. और BFS और level of traversal का हमेशा एक ही कोड होता है, एक boiler plate है, आप याद कर लो, याद क्या कर लो, आप 2 बार कोड करोगे आपको याद हो ही जाएगा, right? You will be remembering it. So that's the BFS code, right? We will using the same boilerplate. That you can clearly see that the queue here. Now we are always pulling out the first element of the queue or the top element of the queue, and then we are visiting to its neighbors, and we are seeing if it is not visited, right? Then visit it, and then mark it, then push that neighbor into the queue. But there will be one more task. There will be 2 more tasks for this question. That will be running an external for loop. That is, we are running BFS for each and every vertex, and while pushing the neighbors, you need to maintain a count variable as well. Now, please pause this video now and give yourself maybe 5 to 6 minutes of time and try to code this approach yourself, because that's very important. Once you've understood the approach, you must code it yourself and then resume back again. Okay, so this is the code for the BFS one. So from here till here is the basic BFS code. What changes we have done is that we have pushed the entire BFS code that is to run for each and every vertex, and that is why we are using this for loop, correct? And after the BFS code is done, we are just seeing, right? While we are pushing the neighbors, we are maintaining a count here. You can clearly see count. So after the BFS is done for each and for a particular vertex, we are just checking if the count is equals to v. That is, we are checking if it has covered all the nodes, because that's what murder vertex means here, right? So we stored that particular I in our answer and we break. Why break? Because we are already starting from I equals to 0 to v, right? तो हमें जब भी जहां आंसर मिल जाए वही हम बोलेंगे दिस विल बी माय मिनिमम आंसर, बिकॉज आई एम ऑलरेडी स्टार्टिंग फ्रॉम द मिनिमम पॉसिबल वैल्यू ऑफ वर्टेक्स, करेक्ट? एंड एट लास्ट वी विल जस्ट रिटर्न द आंसर. So for here, this for loop will run how many times? It will just run for I equals to 0. It will go inside this if condition. Answer will be stored as 0 and it will break from there. Correct. Let us compile and run. While it is compiling and running, what would be the time and space complexity? Now this is up to you guys. Please pause this video here now again. Try to think of the time complexities. It's very simple again. And okay, let us assume with the time complexity now. So what is the BFS time complexity? First of all, tell me that. तो अगर आप देखो इस क्यू में what are the number of nodes that you are visiting, right? We are visiting each and every node, right? That is the from the source node where we were starting, that each and every node have the connection to it, right? So let us assume that each and every node has a connection. That would be the worst case, that will be visiting each and every node. So the time complexity will be nothing but v plus e, right? For each and every vertices, we are going all the edges, correct? Now what is the space complexity? Space complexity is what? Now, at any particular level, what are the number of nodes that you are storing? Okay, so that's about the time complexity. And what is the space complexity? Again, I'm saying we are discussing just the BFS and DFS approach in this video, right? Okay. So visited array हम एक use करेंगे यहाँ पे of v size, right? So that is why I'm saying the space complexity will be O of v. But we are running the BFS for each and every vertices, right? So I will say that v plus e will be multiplied by v again, correct? Okay. So compilation has been successfully मतलब run कर चुका है यार. And let us see the constraint. So the constraint is very low, very low. So if we replace the 500 star 500 plus what are the edges? Let's say 500 will be in terms of v, right? Then you can clearly see that this is nothing but much lesser than 10 power 8, right? So if our code and approach is right, which is, then it should successfully get submitted. Let us wait for the submission and then we can move ahead with the DFS approach, and then you can see that how the time complexities are changing here. Okay, so this is definitely strange. Guys. So our logic always beholds. ये हमेशा काम करता है यार. So if it is showing TLE in the compiler, then that means the constraint the constraint that they have set is not correct. Definitely. And we have seen this many times in the GFG question, what to say. Definitely, they have not constrained they have not set the constraint this at the correct, because किसी एक constraint के लिए definitely वो greater than 10 per 8 हो रहा है, and that is why getting that TLE. Correct? But okay, well, I hope we are at a good understanding with the approach and code. Now let us move ahead with the second, the DFS, right? Again, if you know how the DFS works, then that would definitely be a cakewalk for you. So let us assume a graph like this. So 0, 1, 2, 3. Or we can do one thing that we can just, okay, let's assume another graph. So 0, 1, 2, 3. And then let's say the attachment is 4, 5, and 6. Correct? So if you call for DFS of 0, what will happen? It will call for its neighbor, right? DFS of 1. Then we also be marking it as visited. Then the DFS of 2 will be called, and the 3, right? Now 3 has no more neighbors. So this is a recursive approach, right? So these all calls are getting stored in a recursive stack. So what will happen at this point? It will trace back. Okay. It will okay. So let us make a visited array as well. So 0, 1, 2, 4, 5, and 6. So we started from 0, it will mark as true. Now we going to 1, it marked as true and true and true, right? For 3, there is no other neighbor, so it traces back. So that is why we are saying that we use recursion here. Trace back to the parent call, and you can clearly see that 2 has no more parents, so it traces back again. Now 1 has some parents. 1 has not parent. 1 has some neighbors, right? So it has 4, so it will visit 4 again. Now 4, let's mark the 4 as true. Now 4 will visit 5, 5 will visit 6, and keep marking this as true, right? So you can clearly see that we just need to run the DFS for let's say for each and every vertex, right? But in this case, since all the nodes were connected to this 0, so if we ran the DFS for just I equals to 0, we already got a full visited array, and that's what we want. That means 0 is our what? Mother vertex, right? But there could be some changes, like in this graph, let's say you are having like this, that let's say there were some changes, let's 7 and 8 were there, and 7 was connected like this, right? So after 6 there is no more neighbors, because 7 is connected to 6, right? It's not undirected, it's a directed edge, right? So you cannot say anything for that. Then what will happen? Your DFS will stop for 0. When you ran it for 0, it will stop by covering all the nodes except 7 and 8, right? So that means you need to run a for loop, that is to handle the disconnected graph as well as the neighbors which are not reached, right? Disconnected graph क्या होता है, जैसे 10 और 11 ऐसे यहाँ पड़े होते, right? So if it have asked you that what are the number of components in this graph, then you can say 2 components, right? Okay, so this 7 and 8 is not reachable by 0, and this 10 and 11 is, so let's just remove this 10 and 11 for now. So that means I need to run for each and every vertex again the for loop, right? And I will call, if it is not visited, of I, then I will call the DFS. The DFS will which parameters? The source node, the adjacency list, and the visited array, correct? So after having this for loop, and also you need to store that let's say your answer, you need to store that source node as well, right? So for I equals to it will be running, and this answer will store as 0, right? But again, so for I equals to 1, what will happen? It is already marked visited here, so it will stop. For 2, 3, 4, and 5, it will not run. For 6 also it will not even run, right? Because everything is marked true, and we are checking here. If it is not visited, then only try it, right? Now for I equals to, what will happen? For 7 it will come and it will say it is not visited, right? So from the 7, DFS call will make, so DFS of 7 will call its neighbors, that is DFS of 8. Now the 8 has no more neighbors, so it will trace back, and the 7 will trace back, and then again answer will be stored as 1, right? तो अगर हमारे पास ग्राफ सिर्फ इतना होता, दिस वाइट लाइन, राइट, तो इस कोड से हमारा काम हो जाता। किस कोड से? अगर हमारा ग्राफ सिर्फ व्हाइट लाइन का होता तो इतने कोड से हमारा काम हो जाता, राइट? बट नाउ यू कैन क्लियरली सी कि अगर हम इस ग्राफ को इंक्लूड करते येलो ग्राफ को भी, देन डेफिनेटली आंसर क्या 1 को पॉइंट करेगा, राइट? बट इसका आंसर एग्जिस्ट करता है क्या कोई ऐसा नोड है which is visiting each and every node? नहीं, 0 can visit 1 2 3 4 5 6, but it cannot visit 7 and 8. Now this 7 can visit 8, right? So there are automatically 2 components here, right? There are 2, like there is no such node that you can visit each and every node, right? So in that case, we need to return what, -1, right? So now the DFS का कोड तो यही है यार, right? तो मैं आपको एक बार DFS का कोड दिखा देता हूँ तुरंत से। तो ये रही हमारी DSA रिपोजिटरी एंड let's just wait. Yep, that's the DFS code, right? So here we are just running for 0, but हमें सारे vertices के रखना है, that is we need a for loop, right? और यहाँ पे क्या हो रहा है, देखो we are just marking that source node as true, and then we are using this for loop to iterate in the neighbors, run till all the neighbors of the current node, right? And then if the neighbor is not visited, recursively call the function. ठीक है, ठीक है। तो यहाँ पर हमारा आंसर 1 हो चुका है, राइट? तो यहाँ पे एक सेकेंड स्टेप और नीडेड होगा। व्हाट इज द सेकेंड स्टेप? The second step is that you need to check for this answer. Right? You need to run DFS again. So I will just write it here. Run DFS again with new visited array. Right? For this particular answer, right? Because because this is what ensuring that this could be one of my potential mother vertex, right? But we do not know that for sure, क्योंकि ग्राफ कैसा है, राइट? तो मैंने जैसे बताया आपको, अगर ग्राफ सिर्फ ये व्हाइट वाला ग्राफ होता है, देन डेफिनेटली आंसर इक्वल्स टू 0 रिटर्न हो, बात खत्म हो जाती है, राइट? बट अगर ग्राफ ऐसा है 780 भी अटैच है, देन डेफिनेटली this one, the updated one, is my potential mother vertex, right? तो हम क्या कर सकते हैं यार, वी नीड टू रन वन मोर स्टेप जहां पे हम चेक करेंगे, वी विल रन अ DFS अगेन फॉर दिस अपडेटेड आंसर, एंड वी विल चेक दैट if my visited this new visited array now have all the true values or not. किसी भी मोमेंट पे हमें फॉल्स मिला तो हम बोल देंगे ब्रेक, पॉसिबल नहीं है इसका आंसर, यू नीड टू रिटर्न -1. आई होप वी आर एट अ गुड पॉइंट हियर, एंड आई एम होपिंग दैट यू आर एबल टू अंडरस्टैंड दिस सॉल्यूशन, राइट? एक और ग्राफ ले लेते हैं यार, एक और ग्राफ ले लेते हैं। लेट्स से 0 2 है, 3 4 and 1, करेक्ट? और ये इस तरह से वर्टेक्स है, फ्रॉम 2 to 0 इट्स देयर, राइट? 2 to 0। तो जब हम DFS 0 के लिए रन करेंगे, तो क्या होगा? इट विल ओनली मार्क 0 and 1 एज विजिटेड, राइट? ये ट्रू मार्क हो जाएगा। Then for I equals to 1 it will not run because it already marked as visited. So for I equals to 2 it will run, and now here the answer is now pointing to 0. For I equals to 2 it will run, and it will mark 3 and 4 as visited because that's its neighbor. So true, 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 and answer would be nothing but 2, right? So answer equals to 3, I equals 3 के लिए नहीं चलेगा, I equals to 4 के लिए नहीं चलेगा, right? So this is what, and also 2 is also pointing to 0, correct? ठीक है, 2 का नेबर 0 भी है, बट दैट इज ऑलरेडी विजिटेड, तो हम इसके लिए नहीं चल रहे, राइट? सो दिस इज माय पोटेंशियल मदर वर्टेक्स, जिसके लिए हमें चेक करना पड़ेगा, राइट? सो द सेकंड स्टेप वुड बी कि हम 2 के लिए एक्सप्लिसिटली चेक करेंगे, राइट? देखो चेक करेंगे तो देखो क्या फर्क पड़ता है, राइट? हाँ, तो 2 के लिए हम चेक किए, तो लेट्स से इट विजिटेड 0 फर्स्ट एंड देन 0 to 1 गया, राइट? हम एक नया बूलियन array बना रखे हैं यहाँ पे। सो यहाँ पे 0 1 2 3 4, तो 2 के लिए पहले ट्रू मार्क हो गया, 0 and 1 ट्रू मार्क हो गया, राइट? अब 1 के बाद कोई नेबर नहीं है, ट्रेसेस बैक, करेक्ट? एंड देन 0 का भी कोई नेबर नहीं है, सो इट ट्रेसेस बैक। नाउ 2 का नेबर है, तो 2 का नेबर क्या है? 3, राइट? सो इट ट्रेसेस बैक अगेन, एंड अगेन 2 हैज अनदर नेबर 4, it traces back again, and the calls are finished, and you can clearly see that each and every values have been marked with true, right? So that's the importance of second step we need here. Okay, so that's enough explanation for this thing, and we're already 18 minutes ahead. So please pause this video now, try to code this approach, and meanwhile, the time complexity. What would be the time complexity? Will it differ from the BFS approach? Definitely. We are just running once. DFS is just running once. At BFS, we are running the BFS for each and every vertex. So that is why V into V star V plus C का complexity आ रहा था. Here, we are just running once. That is visiting each and every visited just once. Right? So it would be V plus C, and the time complexity would be V plus C, and the space complexity would be O of V, because it will involve the visited array plus recursive stack space. In the worst case, the recursive space will also be O of V, right? Okay, great. So you can say O of 2V, but ignoring the constant is O of V. Now please pause this video here, guys, and try to code this approach. Yep, and resume again in 5 to 6 minutes. And before moving ahead with the, what is it? Java method 2. This is the C++ code for the method 1, and do not worry, I'm just scrolling it down for you guys. All the description source code would be there in the DSA repository. I will mention the link in the description, right? So do not worry for the source code. Let's just proceed ahead with the logic now. Great, the compilation has been successful. Let's hit the submit button for this code as well. Okay, so it's the TLE. Again, we are good at the constraint analysis. Something is wrong with the input constraint that is given, right? Okay. Okay, I've commented down the first approach, and that's the second approach here, right? So let me just give you a very quick code walkthrough. So we have initialized an answer -1, -1 because if answer is not possible, we'll return the -1, right? Now we are running the for loop for each and every vertices, but it may look like that we are running the DFS for each and every vertices, but it's not true, right? We are not visiting it. We are not running the DFS for the visited vertices, right? So that's what this if condition is helping us, right? So that's a very basic and very standard DFS code, right? Okay, when the DFS is finished, we need to store that answer. Now, I explained you in very detail why we need to check this second step. That is why we need to run the DFS for this potential mother vertex, right? Which is stored in this answer. Now we run the DFS for that, and then we are with the new visited array. Of course, we are naming it as visited 2. Now we are checking that if any value of this visited 2 is marking as false, then definitely none of the vertices are possible in the graph which can visit to each and every other vertex. That means none of the mother vertex is possible. So if that's the case, we are just returning -1, and at last we are returning the answer, right? I hope that makes sense here. I tried my best to explain this thing. Okay, so now this is the standard DFS code, how we are doing the recursion. So the node is passed, that is the source node is passed, the array list ADG is passed, because this helps in iterating the neighbors of that passed node, right? And the boolean visited is passed. So the first step is that we mark the visited of node as true, and then we traverse into its neighbor using this for loop. Then that's the smaller version of the for loop, they're using the semicolon, or we can also say for each. And then we are using an if statement that if it is not visited, then recur, right? Great. So it is compilation, and it has been compiled successfully. Let us hit the submit button. Again, what is the time complexity? V plus E, not V star V plus E, right? The BFS was taking V star V plus E because we are running for each and every vertices. What is the space complexity? O of V. So O of V, why? Because we are using a visited array of V size, and then we are also the recursive stack space will also be involved. Now, if you don't understand the recursive stack, I'm not explaining here. Go ahead and watch the DFS video. Okay, so the question has been successfully completed. Now let us look at the C++ code, and then we can end this video as soon as possible. Okay, so that is the C++ code. Let me just scroll it through. I'll not give you a code walkthrough again. The same thing is happening in Java and what we are discussing the write down, right? So the answer variable, the for loop, running the DFS for the vertices. If that vertex is not visited just once, correct? Then we are checking it again for the potential mother vertex we have stored in answer, and then we are returning the answer, and then there's a simple DFS function marking the node as true, recurring for all its neighbors if it is not visited. Now, I've already hit the submit button, and you can clearly see all the test cases has been passed successfully. Now let us end this video here. Let us end this video here and meet again in the tomorrow's Purity day streak of 314 and the continuation of our graph playlist. Till then, keep learning, keep growing. Bye bye, and take care, guys. तो मिलते हैं कल.